A couple minutes of this lecture will be cut off. That's okay. What's the sign of x plus pi? Negative sign of x, because adding pi to an angle amounts to a flip over the origin. What's the cosine of x plus pi?
Cosine of x.
Almost?
Negative.
Negative cosine of x. And right, one way to remember that is let's draw a unit circle. So if there's an angle called x, adding pi to it will flip it over the origin. So notice that sine and cosine will become negative sine, negative cosine. So both sine and cosine flip. And what does that simplify to? Negative sine of x divided by negative cosine of x is sine of x over cosine of x. The negatives will cancel. And what's sine of x over cosine of x? Tangent. So let's just look at the beginning and end of that. So tangent of x plus pi is the same thing as the tangent of x. So that means that if I take the graph of tangent and shift it, I guess here I see to the left by pi, I should get the exact same graph again. And that means I should also be able to shift it to the right by pi, and I'll get the exact same graph. So what's the period of tangent? It's pi. It repeats every pi. And maybe just for the sake of recall, what's the period of sine? What's the period of cosine? Also 2 pi. So tangent has a shorter period than sine and cosine, even though it's built out of them. So that means if I can sketch the graph of tangent between 0 and pi, then I'll be able to just repeat whatever pattern I see, and then I'll have the graph of tangent over all of the real line. So let's do that. Let's start by thinking about where it's positive and where it's negative, and we'll do that by remembering the graph of sine and cosine, which we just got, so I'll just copy them down. So there's the graph of a trig function. There's another trig function between 0 and pi. Which one of those should be cosine?
Cosine's the one that starts at the top.
Yeah. So this one is cosine. I guess I should have color-coded these. I have the colors. That one is sine. So there are those graphs. By looking at those graphs, tell me, where is cosine positive?
One to pi over 2.
The origin 0 to pi over 2.
Yeah.
And I guess from pi over 2 to pi, it's negative. And that makes sense, right? 0 to pi over 2, that corresponds to quadrant 1 and then quadrant 2. What about sine? Between 0 and pi, where is sine positive? It's just positive between 0 and pi. And remember, tangent is sine over cosine. So between 0 and pi over 2, is tangent positive or negative? Between pi over 2 and pi, is tangent positive or negative? Negative. Nice. So I'll put those down here because this is where I'll get a graph in just a little bit. It's positive between 0 and pi over 2, negative between pi over 2 and pi. The next thing that I'll try to get right in my graph is I'll try to get the border asymptotes correct, and I'll try to get the x-intercepts correct. So tangent, right, it's a fraction. So if you want to know where its x-intercepts are, you should just figure out where the numerator is 0. So tangent is sine over cosine. Where is the numerator of that fraction 0?
0.
So it's 0 when sine of x is equal to 0. That happens when x is equal to 0. Does it happen any other time? Well, it happens also at pi, right? So it happens at x equals 0 and x equals pi. Right, because right now I'm only looking between 0 and pi because I only want to graph between 0 and pi. I might also know that sine of is 0 at x equal to 2 pi and 3 pi and 4 pi, but I don't care about those numbers right now. Tangent has a vertical asymptote when the denominator is 0. So, by looking at the graph of cosine between 0 and pi, where is cosine of x equal to 0? Pi over 2. Let's put those in the graph. So it should have an x-intercept at 0. It should have an x-intercept at pi. It should have a vertical asymptote at pi over 2. And there's the information that I have right now. What do you think? Is that enough information to sketch a graph? So at that x-intercept, it should go from being 0 to being positive. And now it needs to get to this vertical asymptote. Then, from this x-intercept to the left, it needs to become negative. Then it needs to get to this vertical asymptote. How do people feel about that? That seem okay? So, this gives me the graph of tangent from 0 to pi. Now that I have the graph of tangent between 0 and pi, how can I get the graph of tangent over all of the real line? I can just repeat, right? It has a period of pi. So that means that if I can sketch it from 0 to pi, then I can get the graph from pi to 2 pi by drawing the exact same picture again. So between pi and 2 pi, it should look the exact same. So there will be this vertical asymptote. Between 2 pi and 3 pi, it'll do the same thing again. Between 3 pi and 4 pi, it'll do the same thing again. Nice. And maybe just because time is going okay right now, let's answer some questions using this graph. What does it look like the domain of tangent is? Or maybe a better question is, what isn't in the domain of tangent? Well, tell me a number that's not in the domain of tangent. There's a number that's not in the domain of tangent. It's got a vertical asymptote. What's that x value? Pi over 2. It's halfway between 0 and pi. Where is that vertical asymptote? 3 pi over 2. Also known as pi over 2, but then plus pi. Pi over 2 plus pi. How about that one? 5 pi over 2? 7 pi over 2? Is there a pattern in that? Every odd multiple of pi over 2? So the domain is all real numbers except for odd multiples of pi over 2. Or maybe another way is all real numbers, but, and then we'll just start listing them. Pi over 2, 3 pi over 2, 5 pi over 2, and I'll never actually manage to stop, so at some point I'm just going to have to put ellipses. And maybe I'll put some on the other side, negative pi over 2, negative 3 pi over 2. And there are ellipses on that side too. People feel okay about that? Right, so the domain is everything except for the vertical asymptotes. What's the range of tangent? Like I heard things that sounded quiet, but they were really quiet. How do you see the graph of, how do you see the domain, how do you see the range of a function from the graph of that function? all the y values you see? What y values do you see on that graph? All of them. So what's the range of tangent? All real numbers. Where is tangent decreasing? No, it is never decreasing. So where is it increasing? Well, kind of. Is it increasing at pi over 2? No. So maybe it's better to say it's increasing on its domain. Same reason you wouldn't say that the square root function is increasing over the whole of the real line. It's not defined over the whole real line. Cool. Any other questions people want to ask about the graph of tangent? Or what? Otherwise, what just happened? Okay, nice. So, if you like, what the point of this lecture is going to be is that same thing that we just did, but 3 more times. Because there are 3 other trig functions to graph. There's cotangent, secant, and cosecant. So let's talk through cotangent next. Do you think I'm going to do something similar for cotangent to what I just did? Yeah. Because cotangent is very similar to tangent, except that cotangent is the reciprocal. It's cosine over sine. So let's even just start with this question. So just thinking intuitively and thinking about what we did on the previous page, what do you think the period of cotangent is? It's probably pi. It's still very similar to tangent. How could it not be? And for that to happen, it better be the case that cotangent of x plus pi had better be the same thing as the cotangent of x. Do you think probably that walk pretty similar to what was done on the previous page should achieve that? Do people want me to take time and go through that? Is there demand? Okay, then I will go through. So let's follow them all. So we'll rewrite cotangent in terms of sine and cosine. What is cotangent in terms of sine and cosine? Cosine over sine, as it says right here. So this will be the cosine of x plus pi divided by the sine of x plus pi. And what is the cosine of x plus pi?
Negative cosine of x.
Negative cosine of x. And you know what? Even though you already know that, let's see it from this picture. So there's cosine. Cosine of x plus pi. So that means I should shift it pi to the left. So I shift it pi to the left, I get to the blue graph. Is the blue graph negative cosine x? Yeah. So it checks out. Same thing with sine. What's the sine of x plus pi? Negative sine x. It looks like the negative signs will cancel, leaving me with just cosine over sine. Is that exactly what cotangent is? Yeah, great. So that means if I can graph cotangent from 0 to pi, then I can just repeat the pattern that I get, and that'll give me the graph of cotangent over the whole of the real line. Did I go back and collect them all yet? Oh, that explains why I don't have a final football. Okay, grab this. That's a difficulty in teaching classes back to back. If I've already done something in the previous class, I get confused and think that I've already done it in this class. Thank you. Okay, nice. So I'm going to do the same thing as the previous one. So we'll start by figuring out where cotangent is positive or negative. Cotangent is cosine over sine. So tell me, between 0 and pi, where is cosine positive? well, we sketched a graph of them, right? So there is one of the trig functions, and there is the other between sine and cosine. Which one of those is cosine? The red one. So if that's cosine, then tell me, between 0 and pi, where is cosine positive?
Can you say that again? Sorry.
Yeah. So where is cosine of x positive? 0 to pi over 2. So that's all I was going for. I want to get positivity and negativity now. So cosine is positive between 0 and pi over 2, and negative between pi over 2 and pi. Where is sine positive? It's in both of those regions positive. Notice it would go differently if I wanted to instead graph from negative pi over 2 to positive pi over 2. And I could use any base period of length pi to do this. I happen to pick 0 to pi. So cotangent. Cotangent is cosine over sine. So between 0 and pi over 2, is cotangent positive or negative? Positive, because it will be a positive divided by a positive, which is positive. And then it will be negative, because it will be a negative divided by a positive. Awesome. So encoding that down here, it goes from positive to negative. Now let's figure out asymptotes and intercepts. I guess x-intercepts first. So there is an x-intercept whenever the numerator is 0. So let's set the numerator of this fraction equal to 0. When is the numerator of that fraction equal to 0? At pi over 2? Right there, yeah. We'll have it when cosine of x is equal to 0, so at x equal to pi over 2. So at pi over 2, there will be an x-intercept. Vertical asymptotes. There will be a vertical asymptote whenever the denominator is 0. Where is the denominator of that fraction 0?
0 and pi.
At 0 and at pi. So you'll say, when is sine of x equal to 0? You'll look at the graph of sine of x. There it is. It looks like it is 0 at pi and at 0. So there will be a vertical asymptote at 0 and a vertical asymptote at pi. Is that enough information to sketch a graph? So you'll notice that I'm ignoring the idea of horizontal asymptotes. And that makes reasonable sense, right? If I only want to sketch something between 0 and pi, I won't see any horizontal asymptotes. Those only happen when x is really, really big, and I'm only looking at fairly small x's. So it should have a vertical asymptote, and it needs to be positive. So right here, will y be close to positive infinity or negative infinity? Positive. So it'll go from positive infinity down to this x-intercept, and then it needs to achieve this negative vertical asymptote. People feel pretty okay? So we've now sketched the graph from 0 to pi. There it is. How can we get the graph of cotangent over the whole of the real line at this point? Repeat. How do people feel about that? Let's ask just some basic questions. What things are not in the domain of cotangent? Looks like multiples of pi, because I see vertical asymptote at 0. So 0 is not in the domain, pi is not in the domain, 2 pi is not in the domain, 3 pi is not in the domain, 4 pi is not in the domain. Looks like the domain is everything except for multiples of pi. What's the range of cotangent? All real numbers.
It's decreasing everything.
And it's decreasing on its domain. It is never increasing. Everyone feel pretty good? Let's do one quick sanity check. You'll notice that that graph looks kind of similar to the graph of tangent. Not the same, but it looks similar. So let's draw the graph. I'm going to draw the graph of tangent on top of this. If you don't want to screw up your notes by doing that, then don't. So if there's cotangent, let's also draw the graph of tangent. So let's see, that one had a vertical asymptote at pi over 2. And then it was 0 at those two places, and it was increasing in between. So the black graph and the red graph there, like they look kind of similar, right? What would you want to do if you wanted to transform the red graph into the black graph? What would you need to do? Flipping it over the y-axis seems like a good start. That would suddenly turn all of the increasiness into decreasiness, and cotangent is decreasing, so that's good. But it still doesn't line up. Like the vertical asymptotes are all in the wrong place.
Yeah, we shifted over.
You could shift it over. How far do you need to shift it? Pi over 2. To the left or to the right?
Right. Or no, it'd be plus, so it's a good
Doesn't matter.
It doesn't matter.
Yeah, pick one. Maybe I'll shift to the left so I can draw a plus sign. So it looks like, let's write down what we just concluded then. We just concluded that the graph of cotangent is the same as graph of tangent after we did two things. After we, let's see, I'm writing over there, so let's zoom in a little bit. After we flip over the x-axis, and then we shift, right or left doesn't matter, but I'll go left, by pi over 2. Well, that means something. So that means that cotangent of x is the same thing as tangent of x, but with some things done to it. How do you change a function when you flip its graph over the y-axis? And you just like stick a negative sign in front of it. That does the job. So the cotangent of x is the same thing as negative the tangent of, well, not quite x. How do you shift a function to the left by pi over 2? Yeah, you add pi over 2 to the x's. So apparently, cotangent of x should be the exact same as negative the tangent of x plus pi over 2. And notice, since we could have gone left or right equally well, that could have been minus pi over 2, and we would have been just fine.
Shouldn't there be a negative sign in front of the tangent then?
Isn't there?
On like a graph for the check? For the sanity check?
Yeah, sure.
Does it matter?
It does. Yeah. Yeah. Notice if you take tangent and you just shift it to the left or right, it keeps on being increasing, so it can't be the same as cotangent. So tangent isn't a shift of cotangent. Do you think we should check if that's actually true analytically, just to see if the graphs are reasonable? How do you think we could check that? Well, could we write it in terms of sine and cosine and see if it just falls out correctly? I think we're doing okay for time, so I'm going to say let's go ahead and do that. So let's do. So I'll just keep this negative sign along for the ride. And maybe to distinguish negative signs from each other, I'll like draw a circle around that negative sign. What's tangent in terms of sine and cosine? Sine over cosine. So tangent of x plus pi over 2 should be the same thing as sine of x plus pi over 2 divided by cosine of x plus pi over 2. And that negative sign, I'll just let it come along for the ride for now. What's the sine of x plus pi over 2? Have I already asked you guys the question of how many people bring all of the previous lecturer's notes to this class when it meets?
Yeah.
I have asked that already? Okay.
Not today, but within like the past week.
Oh, okay.
Wouldn't this just be sine of x and cosine of x? Is it?
Nope.
Well, when you look above, I don't know, I'm confused then. Because like when you look at the, oh no, just kidding, because it, okay, never mind, actually, I kind of forgot.
Yeah. So I am going to pull up this note packet. Does one of those identities tell me what the sine of x plus pi over 2 is? Yeah, I guess, well gosh, that means I have to actually look at it. There's a sine of x plus pi over 2, except it's theta and it's in the wrong order, but that doesn't matter. So what's the sine of x plus pi over 2 the same as? Just cosine. So this negative sign with a circle around it will just come along for the ride. Negative cosine of x divided by, what's the cosine of x plus pi over 2? A negative sign appears. Is that the same thing as cotangent? Oh, that's good. That's nice. All right, so if the graph tells you that an identity should happen and that identity doesn't actually happen, then your graph's wrong. Cool. So there's the graph of cotangent. There are two more functions on our list, secant and cosecant. What's the formula for secant of x? 1 over cosine. I guess it says that up there, so it's a silly thing for me to ask. So if I want to understand secant, let's just understand cosine. What's the period of cosine? 2 pi. So cosine will repeat every 2 pi, so 1 over cosine will also repeat every 2 pi. So let's graph secant just over one period. So one interval of length 2 pi. And see what happens. So I'll just graph it from 0 to 2 pi, and then I'll repeat it. So let's start with the graph of cosine. So the graph of cosine looks something like this. And I want to get the graph of secant, which is 1 over cosine. So first let's figure out where secant should be positive or negative by figuring out where cosine is positive or negative. So between 0 and pi over 2, is cosine positive or negative?
Positive.
Between pi over 2 and pi?
Negative.
Between pi and 3 pi over 2?
Negative.
3 pi over 2 to 2 pi?
Positive.
So what about secant? What's 1 over a positive number? What's 1 over a negative number? So the positivity, negativity should be the exact same? Gesundheit. So the graph will eventually appear down here. It'll go positive down to negative. It'll stay negative and then become positive again. A fraction is 0 when the numerator of that fraction is 0. When is the numerator of this fraction equal to 0? Nope, when is the numerator of that fraction equal to 0? What's the numerator of that fraction? When is 1 equal to 0? So there will be no x-intercepts to talk about. There will be a vertical asymptote whenever the denominator of that fraction is 0. When is the denominator of that fraction 0? Yeah. X equal to pi over 2, and x equal to 3 pi over 2. Because you can see the two of them. One's right there, one's right there. So I see a vertical asymptote there, and I see a vertical asymptote there. And I think the main thing I want are just like some sample points, but I want like sample points that tell me as much as possible. What's the most extreme value? What's the biggest value cosine can take? What's the maximum value of cosine? 1. So if the maximum value of cosine is 1, as long as you don't think too hard, that should mean that like 1 is the smallest value 1 over cosine should be able to take. Of course, that's not true because like negative numbers will screw it up. But that means that let's think about that. That'll be like a local extremum. So tell me, when is secant of x equal to 1? Well, let's go through some algebra. So you want to solve the equation 1 over cosine x equals 1. And it looks like the side that has the x's is like a fraction. So let's make it so there's not a fraction there. How could you rewrite that so there's not a fraction? You could multiply both sides by cosine, or you could take the reciprocal of both sides. Both will achieve the same goal. You'll get 1 equals cosine of x. Oh, nice. But I have the graph of cosine of x, like it's right up there. No, well, it's off the screen. By looking at that graph, where is the cosine of x equal to 1? At 0, and where else? At 2 pi. So that means this graph should go through the point 0, 1, and, oh, that's not where I should have drawn that point, at 2 pi, 1. Let's play the same game, but for negative 1. So if you want to know when secant is equal to negative 1, well, how could you rewrite that in terms of cosine is equal to something? If 1 over cosine is negative 1, then what is cosine? Okay, so you've gone all the way to the end answer. So cosine should be negative 1. You look up at the graph. Cosine is negative 1 at pi. So the graph should also go through the point pi, negative 1. And I claim that that's enough information to sketch a graph of this function. So since those points at y equals 1 and negative 1 should be like peaks and valleys, respectively. All of these should be valleys. All of that should be a peak. And there should be another valley here. So there's the graph of secant between 0 and 2 pi. How can I get the graph of secant over the whole of the real line now? I can repeat that same pattern? Though, I mean, maybe first I should ask, do people have any questions about how that much appeared? Everyone's happy enough? Okay. So now I'll just take the same picture, and I'll repeat it. I guess I've been doing that in red, generally. Cool. I guess we can answer some questions. Let's start writing down, I don't know, some intervals of increase or decrease. Maybe we could ask this first. Is this function either never increasing or never decreasing? It's got places where it's increasing and it's decreasing, so there's something interesting to do here. Now let's just start listing some intervals of increase. It looks like it starts increasing at 0. How far to the right can you go while still having it be increasing? Pi over 2, I think? Because then there's a vertical asymptote. You can't include vertical asymptotes because the function's not even defined. Oh, yeah. So it's increasing from 0 to pi over 2. After pi over 2, does it continue to increase or does it change to decreasing? Look carefully. It continues increasing. Right, so it increases, it has this vertical asymptote, it resets to negative infinity, and then it keeps increasing. At pi, it switches to decreasing. Until it hits this vertical asymptote, and then it continues decreasing. And maybe we'll read off one more thing on this. Or maybe we'll say some things aloud. What numbers are not in the domains of this function?
Multiples of pi over 2.
Yeah. Maybe I'll say odd multiples of pi over 2. Because like pi is a multiple of pi over 2, but pi is in the domain. So the domain equals all of the real line, right? Blackboard bold R for the real numbers, except odd multiples of pi over 2. And maybe last thing, range. What numbers are in the range of this function? So let's just start drawing some things. So are these numbers in the range of the function? Yep. So far so good. When does it change? Because suddenly it's not in the range, right? So where was that change value? -1. So it looks like the range is negative infinity to -1. Should -1 be in the range? Is it included? Yeah, because it's on the graph. Together with 1 to infinity. Everyone feel pretty good? So the one item left on the list is the graph of cosecant, which is 1 over sine. And I'll give you guys one of two choices. Either this can be an exit quiz. As soon as you guys have a graph of cosecant that you share with me and I'm happy, then I let you lead. Or I can keep talking for the remaining 6 minutes. People want me to keep talking? Okay, then I will. So let's try to figure out the graph of cosecant, which is the reciprocal of sine. So, tell me, where is sine positive? Or maybe we should start by just remembering the graph of sine. There it is. So between 0 and pi over 2, positive or negative? Positive? Between pi over 2 and pi, it looks like it's still positive. Pi to 3 pi over 2, negative. 3 pi over 2 to 2 pi, negative. And so the same should be true for cosecant also, because cosecant is just 1 over sine. So cosecant should be positive, and then it should switch to negative. Everyone with me right now? So next, let's find the x-intercepts. Where does cosecant have an x-intercept? It doesn't. The numerator of that fraction is 1. 1 is never 0. Same as we saw for secant. Cosecant is equal to 1 over sine. It will have a vertical asymptote whenever that denominator is 0. So if you're only interested in numbers between 0 and 2 pi, where are the vertical asymptotes of cosecant? At 0, at pi, and at 2 pi? At 0, at pi, and at 2 pi. Let's figure out So just as with secant, there will be peaks and troughs when x is equal to 1 and when x is equal to negative. So let's figure out when that happens. So tell me, what x values result in cosecant equals 1? Pi over 2. And maybe I'll draw that dot up there. Is that enough information, or do people want me to talk through that in any more detail than none at all? Okay. Where is cosecant equal to negative 1? 3 pi over 2. Does anyone want me to talk through that one in any more detail than none at all? So let's draw those. So there should be a peak, nope, a value right here. Yeah. At pi over 2, comma 1. Or it should look something like that. Then there will be a peak right here at 3 pi over 2, comma negative 1. And I'll see the top of a hill right there. And now let's just extend that so I get those water glass asymptotes that I know I need to get. There we go. And now how can I get the graph over the rest of the real line? Repeat that pattern. Yeah. Cool. And I guess one thing that you can notice now is, does that look pretty similar to the graph of secant? In fact, if you drew the graph of secant next to it, you think it would look like a shift. Cool. So I'll stop there. As a reminder, I do have homework that should be graded by the end of the day. If you are very impatient and you want to see your homework like during my office hour, come on by. There's a midterm on Monday, so show up for that review on Friday.
I just want to make sure I'm not like thinking words for like this. It's like an A and shift it up. Cosine. To get x plus pi over 2.
Yeah, so let's take a look. It's possible that I just did things wrong.
Oh, yeah.
Well, let's start at the graph of
I
cosine.
know, I just remember one. I got a weird, like,
This one's the graph of cosine.
I think you took sine of x plus pi over 2 pretty easy.
Yeah, okay.
I just want to make sure I wasn't thinking about it backwards.
Yeah, so let's check both of these. So sine is this one.
But that's cosine.
That's cosine. Oh, there's my problem. There's the graph. Take that and shift it right by pi over 2. No, this one's
D is sine. D is negative.
D is negative sine. Okay, and I want to compare it to cosine, which is A. So take A, which is left by pi over 2. I got that.
Okay, I just want to make sure I wasn't thinking about it.
No. I'm the one who was being organized.
That's right.